Hello and welcome to this video. Today I have some fun stuff prepared for you. We are building a modded Gotek Floppy Emulator with the FlashFloppy software, which is open source. We load some data onto a USB thumb drive and then build the Floppy Emulator into the Yamaha SY77. So let's get started. To replace the stock firmware of the Floppy Emulator, we first solder some pins onto it and use these pins to flash the software with the serial programmer. There is also a second method to program FlashFloppy onto the Gotek floppy drive, which is maybe even easier. You can find a guide for this method on the FlashFloppy website. So here we have the case open now, and we take the PCB out. On the right hand side of the PCB, you can see where we need to solder the pins. Later on, we will replace the 3-digit display with an OLED display, so we just disconnect it for now. Next, we create pin headers with 5 and 4 pins. And we start to solder them onto the PCB. The pins are soldered and ready to use now. For the serial programming, I've actually built my own cable. This is not really necessary though, you can just use normal jumper wires. So the one end of the cable goes into the serial programmer. The other two ends go to the power and TX and RX pins on the PCB. So let's connect them now. On the upper left of the screen, there is a picture from the FlashFloppy wiki, which shows how to connect the cables. In addition to that, we also need to set the boot jumper in order to get into flash mode. Next, we connect the prepared cable to the serial programmer. Make sure that the jumper on the serial programmer, if it exists, is set to 5 volts. So this concludes the preparations on the hardware side. Let's take a look at the software side of things. The first thing that we need to do is to make sure that the serial programmer is recognized by the operating system, in my case Windows 10. And as you can see, I still need to install a driver for that. Depending on what serial programmer you have, this step might differ. We just unpack the drivers and then install them in the device manager. For some odd reason, the serial port is still not working properly, so we just install the driver a second time. And as you can see, the port is working now and is assigned to COM3. Next, we download the Flasher software. For that, we use the official STM32 demonstrator Flasher software from ST Microelectronics. Again, there are multiple ways to do that, and there is different software available for flashing. I'm using the official one. For that, you have to go through some registration and login annoyances though. As you can see, the program runs. It lists COM3 for our serial programmer, but we still need to download the FlashFloppy software, so let's do that now. FlashFloppy is an excellent software, which has a lot of features in comparison to the stock firmware. It's open source, and if you like it, it's a good idea to make a small donation to the author. So let's do the programming now. We select the COM port. We should probably select a lower baud rate. It seems to be more stable. And the next step, we are asked to remove the protection. In my case, this always takes some time, and maybe I also need to restart the software, which is what happened here. This time I select a lower baud rate, as it seems to be more stable, but higher ones should work fine as well. And this is it. We have successfully flashed the FlashFloppy software to the Gotek Floppy Emulator. So the next step is to realize the hardware modifications to make the Gotek Floppy Emulator a little bit more usable. We have 3 modifications that we are doing. The first one is the OLED display modification, the second one is the Rotary encoder modification, and the third one is the speaker modification. Let's do the OLED display first. This is what the OLED display looks like that I'm using. FlashFloppy supports different sizes, but this one fits pretty well into the case. The display is an I2C display, so we have 4 pins that we need to connect. The picture from the FlashFloppy wiki shows how the pins need to be connected. To test the OLED display, I again connect the serial programmer to the USB port with only power connected, and the display doesn't work. So next I swap SDA and SCL to correct the wrongly connected pins. And we have some success. The OLED display works and the FlashFloppy software reports as version 3.23. Next, let's install the Rotary encoders. The default Gotek hardware only has 2 buttons, and the Rotary encoders add rotation and navigation to the right and to the left, as well as a 3rd button. For that, we again need to do some soldering. First, we need to open 2 holes where we need to add pins. To do that, we add some flux and remove the solder from the holes with some solder wick. One important thing about these 2 pins to solder is that it's better to use angled pins here, because otherwise if you use normal jumper wires, they might fight with the case in the end. Next, we work on the necessary cabling to connect the Rotary encoder to the PCB. For that, we remove isolation from the jumper wire and then solder the jumper wire to the corresponding pins on the Rotary encoder. To improve isolation of the jumper wires, we use shrink tubing to separate them from each other. Here I put some initial tin on the pins of the Rotary encoder. And then I solder the pre-tin jumper wire to the corresponding pin on the Rotary encoder. We put the shrink tubing over the pin that we have soldered and then shrink it. Please note that what I'm doing here is not a very good idea. Using the soldering iron tip to shrink the tubes may mess up your tip. Next, we connect the second ground pin. Again, please don't use your tip to shrink the tubes. In the next step, we tin the ends of the shortened ground wires and solder them together. And finally, we connect it back to a wire with a DuPont connector at the end. And there it is, the rotary encoder with all the necessary cabling to connect it to the PCB. So let's connect it to the PCB according to the instructions of the FlashFloppy wiki page. Looks good, so let's test it again. We again connect power from the serial programmer. And for testing, I put in a USB thumb drive, which contains a few floppy disk images already. And as you can see, the names of the disk images are displayed on the OLED display, and by rotating the rotary encoder to the right and to the left, I can navigate through them. By pressing the button, I can go into the FlashFloppy disk menu. For the last modification, we install a speaker that kind of simulates the sound of an original floppy drive. Here we can use just normal jumper wires and use the instructions from the FlashFloppy wiki page for the cabling. Finally, let's do some work on the case. Note that I'm taking a little bit too much plastic here away from the ride. It's best you measure it properly. Next, we use hot glue to put the rotary encoder in place. And the same for the OLED display. And there it is. It looks nice, except that I've taken away a bit too much plastic for the display. There is one little thing left that we have to do, and that is we have to take away a bit of plastic from the top of the case, because now the OLED display and the rotary encoders are in the way. Our modified Gotek Floppy Emulator with a FlashFloppy firmware is now almost ready to use. The last thing that we have to do is to adjust the jumpers at the backside to our target system. As I plan to install the Gotek Floppy Emulator into a Yamaha SY77, I have to put jumpers at the pins MO and JC. This information can be found on the FlashFloppy wiki as well. For the Yamaha SY77, we need to have an adapter, because the number of pins on the Yamaha SY77 is different from the standard 3.5-inch floppy disk drives. You can get these adapters on eBay. Here the important thing is to find pin 1 on the adapter and the Gotek floppy disk drive, so that the orientation of the adapter is correct. So now we are ready to build it into the Yamaha SY77, so let's do that. As you can see, the process is pretty straightforward and doesn't need a lot of explanation. So now that the floppy emulator is built into the Yamaha SY77, we should take a look at how we can build the disk images for the USB thumb drive. Again, there are a lot of ways to do that. I use a software called WinImage, but you can also find free software to do that if you like. The first thing we need to make sure is that our USB thumb drive is formatted in FAT32. As you can see, I have prepared a few folders from sounds that I've purchased, and I want to create disk images from them. FlashFloppy allows navigation through folders, so for each of these companies we create folders. Next, let's download and install WinImage. For the Yamaha SY77, we have to make sure to create 720 kilobyte disk images. Drag and drop does unfortunately not work with WinImage. You have to inject the folder to add the files to the disk image. The file is added, let's save the disk image. All done. The dance producer disk image is ready, let's create a second one. It's maybe interesting to note that there is really a lot of software available that allows you to work with disk images. For example, there is a tool called IMDisk Toolkit that allows you to mount disk images in Windows 10 to a disk drive. On OS X, it seems to be possible to mount IMG disk images directly from the Finder. In those cases, all you need to do is to create empty disk images and just copy them. Personally, I haven't tried these methods and I just stick with WinImage. So let's just fast forward through the creation of the remaining disk images and then let's have a small demo with the Yamaha SY77. As there isn't much left to say now, I hope you enjoyed this video and see you next time.